If we want to add two 4-bit binary numbers together, then the addition of these numbers will produce 4 sum bits and 4 carry bits. The carry out bit from one set of bits is added as a carry in bit to the next set of bits with greater weight. Notice that every addition except one adds 3 bits together. To truly make this operation on every set of bits the same, we need to include a carry in bit to the entire operation, and we'll make it a 0. Now that we do the same procedure with every set of bits, we want to create a module called a full adder that will perform the same operation with every set of added bits. If we design this component correctly, then we can chain several of these modules together to create our more complicated circuit. The process of creating one module that can be replicated several times is called modular design. Modular design is one of the most important concepts that we use in digital logic. Based on our modular algorithm, a full adder will receive 2 data input bits and 1 carry in bit, and it will transmit a sum bit and a carry out bit. We will use K-maps to help us find minimal solutions for the full adder circuit. To work through the variety of inputs, we will start with the case where all inputs are 0. The sum and the carry out in this case are 0. If we change Cn to be 1, we find a new sum and carry. Actually, we find the same combination of sum and carry outputs as long as only one of A, B, or Cn is 1. If 2 of the input bits are 1, then we will find that the sum is 0, but that the carry out is 1. Finally, if all 3 inputs are 1, the sum is 1, and the carry out is 1. The K-map for the sum output shows us that we cannot create a convenient minimal expression for the sum output. However, because the sum is 1 whenever an odd number of input bits is 1, we can simply represent the function as 2 sets of XOR operations. The carry out bit simplifies a little nicer and is 1 whenever 2 or 3 input bits are 1. If we create a circuit based on these expressions, we can create our 3-input, 2-output module called the full adder. We can then combine several of these modules together to create 4-bit adders, or larger size adders for that matter. If we plan to add 2 4-bit numbers, like the original example, then we also need to make sure that we input a 0 into this first carry in.